science says that water expands 9% when it freezes. But does that mean you can leave 80% of the water in your sprinkler pipes and it won't freeze? How much water should you blow out so that you can save your sprinkler system? So let's get started. What I'll do is take different types of sprinkler pipe that are common in irrigation systems and fill them with different amounts of water. Then we'll put them outside during a snowstorm when the temperature drops and see what happens. I love to see things break. That's always fun. Okay, so now we're in the shop. We've got 4 different types of pipe that we're gonna be using. And what we're gonna do is cut up the different types of pipe into sections so that we can use a scientific method to figure out how much water will freeze and break a pipe. So now we've got all of our pipes cut. We've got one end sealed so it can hold the water. So we've got our 4 sections of the Schedule 40 right here, which is a little bit thicker PVC, SDR 21 or the Class 200 here, and I'm also using 1 inch for that. The black 1 inch poly, this is 1 inch, and I went with 80 PSI on this one, 3/4 inch Type M copper. Now the copper, the Type M I'm using, is a 3/4 inch. The reason I chose these is because they're the most commonly used in the sprinkler system. So we've got one end sealed on all of these so we can fill it up with water. Once it's got water in it, then I'll seal up the other end. We're gonna fill one up to 100% full of water. The next one, 75% full of water, 50% full of water, and 25% full of water. And we'll see which ones freeze and do the most damage. And how we're gonna measure that is we have these sections of pipe here. So this is the SDR 21, Class 200, Schedule 40, copper, poly. We'll use these to fill those up. Okay, so we've got all the pipes filled up, and just to make sure that we're at 100% on the copper, because when you sweat it together, it would evaporate the water. Just to make sure we're at 100%, I made sure to put this cap in there. So we're 100% on this one, and we're ready to go. And as a bonus question, I'm curious to know what you think. So we've got Schedule 40 and Class 200 or SDR 21. Which pipe holds more water? Let me know in the comments below, and I'll let you know at the end of the video. So I'm going to put them out on a wooden shelf so that they can be fully exposed to the temperatures, and we can get a really good reading on whether or not they'll freeze and break. So here's the copper pipes. We got 25%, 50%, 75%, and 100% full. Then the same thing with the PVC. This is the Class 200 SDR 21, the 80-pound test of 1 inch poly, and then the Schedule 40 PVC 1 inch. So I've got all the pipes laid out on the shelf here, and cold weather coming in. I am super stoked about watching this stuff break, and I'm excited to see the results. Well, it is 8 degrees outside. No, it's -8 degrees outside. And I'm checking on the pipes to see how they're doing in this cold temperature. Oh yeah, we got one missing there. Probably froze right away, popped off. Let's check these guys here. So the copper pipe only froze, the one that was 100%, froze right here, you can see. I don't think any of these others froze. All right, so now the SDR21, the class 200. This is the 25%. That's slush. This one was 100% frozen, or 100% water, and it definitely has a bulge right there. Has a bulge right there. Has a bulge around here. But it didn't crack. All right, so the poly, there's like a little split. Not a full split, but it looks like it had expanded right there. You can zoom in on that. You see it right there? It looks like it expanded just a little bit. But it didn't break all the way through. Interesting. Yeah, and then the Schedule 40. %75% is good. The 100%, I don't know where it is. Here we go. I think this one broke. That's part of it. Look at that. All the way through. Goodness. Blow out your sprinkler systems. We'll have to find the rest of the parts of the Schedule 40 when the snow melts. So what were the results? Well, of the 16 pieces of pipe, only 4 of them were filled up 100%. Each one of those was affected by ice. But why did some of the pipes freeze and burst and others only froze and expanded? Well, it has to do with the strength and the makeup of each of those materials. So the copper burst right away. It got colder faster than the PVC, and the end burst open. The Schedule 40 completely blew apart. If you saw on the Class 200, it bulged and expanded in a few areas. It didn't burst, and that could be due to a couple of things. One, it may not have been 100% full of water when it froze, but also it could allow for that contraction. It's a thinner wall, so it allows for a little bit of expansion. Now, it has a weak point in it once it expands. The Schedule 40 is a thicker pipe, so as that water expands, it puts a little bit more pressure on it, and when it gets to its bursting point, it lets go and it shatters. The Class 200 will do that, but in this case, it didn't have as much pressure built up, and it only expanded, it only bulged. Now the black poly, when it froze, it expanded, but it didn't burst. And that's because it's a different makeup than the PVC. It allows for a little bit of that. Now, does that mean it's okay if it freezes? No, because where it has expanded is now a weak point. So just because you forget to blow it out, it may have frozen, but you may not have a leak right away. But you will. Down the road could cause problems. Should you blow out 100% of the water in your sprinkler lines? Yes. Is it possible? No. There's no way to get 100% of all the water out of your sprinkler lines every single time. So do the best that you can. Try and get out as much water as you can to give you the best probability of not freezing and damaging your pipes. So when you're blowing out a sprinkler system, you can tell how much percentage of water you've blown out by paying attention to the heads. So for example, if you look at a sprinkler zone that you're blowing out and there's 4 heads, the one closest to the source will blow out first. The last one will have the most water in it and take the longest. So as you pay attention to that, look to see that first head will be almost 100% air coming out. Then after that, the next one will be almost 100% air coming out, third and fourth. So for example, if you have 4 heads on a line and 2 of them are blowing out 100% air, you're easily 50% blown out. It makes sense. Now, as you get to the end, if you have one head left on the line and all the others are blown out, there's only air coming out and one head still has water, keep blowing it out. But if you had to stop, you're probably safe, at least 75% safe. So now bonus content. The question I asked earlier was, which pipe holds more water? Now we have 1 foot class 200 SDR21 and 1 foot of schedule 40. So which holds more water? Okay, so I filled up the 1 foot section of schedule 40. We're gonna put it in this vase and find out. Every drop. So it looks like we have filled the water up about a cup or so. So I'm going to dump this out and I'll fill up the class 200 pipe and dump that in and see how much more water we get. Okay, so now I've got the class 200 pipe filled with water. We're going to dump it in here. So the class 200 actually holds just a little bit more water than the schedule 40 does. So hopefully you can see here the class 200 and the schedule 40. Now I'm curious what 1 foot section of 80-pound poly pipe. I wonder how much water that holds. Just slightly less than the schedule of 40. So schedule 40 has the least amount of water in it, and the poly and the class 200 have the most amount of water in it. So you can see the difference in thickness of the walls of the pipe. And this is why we got different results for different pipes. Now, why is that important? I'll talk about that in the next video.